Hello everyone. Welcome back to the course of data structures using C language. This video is brought to you by Newton's group of institutions Macharla. This is Aravind Yegireddy from the Department of Computer Science and Engineering. In the last session, we have discussed some of the operations on the double linked list, like how to append an element in the double linked list, how to add a node at the beginning of the linked list, and how to find the length of the list and how to display the elements in the double linked list. Now in this video, let us discuss how to add a new node after a specified location. Assuming that there are already some nodes which are available in the list like this with root pointing to the first node. So this is the list we are considering with 4 nodes in it. Now we have to add a new node after the specified location. Here we are taking a function void added after, and here the function name can be anything. And we know that the temporary operations in a linked list will take place with the support of the temporary variables only. So let us first declare one temporary variable temp, which is a struct node pointer type. Then we have to read the location where we have to add the node. That is the location after which we have to add the new node. Then, so here we need to display the information saying that printf enter the location to be added for adding the new node. So using the scanf function, we need to read the location into one variable called LOC. So that we have to declare that variable LOC. And suppose that the location is 7. And here the list is having only 4 nodes. So can we add the new node at the location number 7? No, it is impossible. So here first we have to find the length of the list. And next we need to check if the location is less than or equal to length or not. So for that we have to declare one more variable len. So here len is equal to, we are just calling the length function. So we have to call the length function, and we know that the length function will return the length of the list that we are collecting into len. So now for this particular example, the length of the linked list is 4. So the 4 value will be stored into the len. Now, if the location is greater than the length of the list, then directly what we are doing, we are printing the message saying that it is an invalid location. And here we are also printing one more message saying that the list contains only %d nodes. That is, in place of %d, we are printing the len value. So if we are given the location value as 3, which is within the limit, then we go to the else block. So in the else block, what we do? We write our code. So in the else block, first we have to create the node dynamically by using the malloc function and assign that value to the temporary variable what we have created, temp. So here we have to do the typecasting, since we know that the malloc function return type is void, which is a generic pointer type, whereas the temp variable, the type is struct node pointer type. So what we are doing, we are implicitly converting the void type into struct node pointer type. So typecasting we are doing here. So the node gets created at a specific location, say 5000, will be assigned to temp, so that the temp will be temporarily pointing to the newly created node. Now we need to read the node data. We have created the data. Now we have to enter the values to this particular node what we have created. So for that, printf, enter the node data. Then using the scanf %d, we are reading the address of temp to data. And next, in the temp to left value, which we are assigning the null value, and in the temp to right value, we are assigning the null value. Now the node is ready. Suppose that we have given the node value say 50. So here we are placing left side, we are placing null value, and right side we are placing the null value. Now the node is ready, and now we have to connect this node after the specified location. So here we have given the location value as 3. So now how to come to the specified location? That is, we have to add the node after the specified location 3. So this is our first node, this is our second node, and this is our third node. So here in this location, we have to add this particular new node what we have created. So how we can come to this particular location? For that, what we are doing? We are creating one more temporary variable. The temporary variable name is P. So we are creating a pointer variable P, and we are taking one more variable I. So here we have declared two variables. One is pointer variable P, and one ordinary variable which is of type integer type I, whose initial value we have taken as 1. Now this pointer variable need to point to the first node and need to travel to the location specified. So here we have to assign the root value to the P. So the P initial value will become 2046. So that the P will be pointing to the first node. Now we have to move the control to the third location. So here we have to write the logic using the while loop. That is while I less than the location, then we need to, if the condition is true, then we need to enter into the while loop. So now we need to shift the pointer of P to the next location. So we write the statement directly like this. That is, P to right value we need to assign to P. So P is equal to P to right. So here in this particular case, the I value which is 1 is less than 3 with the condition is true. So the P to right value is 5048. So that 5048 value we will store it into P. Then once after storing the value of P, what we need to do? We need to increment the I value. So I plus plus. So now my I became 2. So 2 is less than location value 3. The condition is true. So again it will enter into this particular while loop. So P is assigned with P to right. What is P? 5048. 5048 to right is 9042. So now the P will be stored with 9042. Then again I plus plus. So I became 3. 3 less than location value 3. The condition is false. So when the condition is false, we come out of this while loop. We don't enter into this while loop. Now here our P is pointing to this particular location. So here now finally we have to establish the connection. Why? Because our P is pointing to the specified location where we have to add the node. And our new node is also ready. So now this node should point. So here we have to point this node to this, and this should be pointed here. So here we have to make these points like this. So we have to give left side 2 connections and right side 2 connections, because this is a double linked list. So always the first connections what we have to give is, we have to give the right side connections. So now here the address of this particular node is 7056. So that 7056 value we have to store it here. We have to store that 7056 value here. So here my I have to store the 7056 value in this particular location. So to store that, we have to store the address of the fourth node. So that will be pointing to, so that this will be, this particular link will be pointing to this particular location. So how? What is 7056? 7056 means what? Value of this location is, it is P to right link. So P to 7056 is nothing but it is 90. P is pointing to the 9042 to right. So P to right is nothing but it is 7056 value. So that we need to assign to where we have to assign. We need to assign that value to this position. What is that? Temp to write. So P to write value we need to assign to temp to write. So P to write value we need to assign to temp to write. So here we are placing P to write value into temp to write. Understood? Then 7056 will be stored here. So 7056 will be stored here. Now one connection is ready. Now since this is a double linked list, so we need to establish the second connection also in the other direction. So here what we have to do? We have to place the address 5000 so that the connection can be established like this. Okay, in the backward direction from this node to this node. So for that, what we have to, what is 5000? 5000 is nothing but it is the temp value. And temp value we have to store into this location. So what is this location? It is nothing but it is, what is that location? It is left location of 7056. But this location we are pointing by P to right. So P is 9042. So 9042 to right is 7056. And so 7056 nodes left link is this particular location. So P to right to, what is this? Left. Pointer to pointer concept. So P to right. P to right is this. The right's left side value we are storing with the temp value. Understood? So this is the connection how we have to give. So by doing that, so here we are giving P to right to left, we are assigning with the temp value. So that connection. So both the connections got established. So now our right side connections are over. Now we have to give the left connections. So here what we have to do, we have to store this 9042 value in this particular location. So what is 9052? 9052 is nothing but P. That P value we have to store it here. What is this? It is temp to left. It is temp to left. So we need to assign the P value into temp to left so that this connection will get established. So the connection will be like this, from this direction to this direction. So three connections over now. Now we have the last connection. What is that last connection? We have to place this 5000 address in this particular location. We have to place that 5000 address in this particular location. So what is 5000? 5000 is nothing but it the temp value. So temp value we have to store here. What is it? It is P to right. So temp value we need to assign to P to right. So now this value also will get stored with 7000. So the connection will get established. So this is how we are going to insert the node at the specified location. That is, we are going to add a node after a specified location. So this is the logic what we are going to use for adding the node at the specified location. Now let us see how to delete a node from a double linked list. So here also we have three cases. So before, let us take a double linked list with root variable pointing to the first node. So this is the list we are considering with 4 nodes in it. So here you can see that the previous pointer of the first node is null, and the next node of the, that is the right node of the last node is also null. So here the deletion of a node means nothing but we can delete the node or we can disconnect the link between the nodes. In the first case, that is the deletion at the beginning. So here, this is the first node. So this is the node what we are trying to delete. And this is the tail node. So if we delete this node at the beginning, then the first node will get deleted. So this node will get deleted and this will be our first node. So 10 will get deleted and 20 will be the first node. So the head should point to this particular node. Understood? And the value here, it should be null value because it is not having connection to any of the previous node. So we have to remove this, disconnect this connection. And at the same time, since this is the first node, this node also we have to disconnect this connection. Understood? So here also we have to place the value of null. So the root need to point to this second node, and here the value need to be null, and here also the value need to be null. That is the previous value need to be null, and in this case the next value need to be null. So if we place the null in these positions, automatically then the links will get disconnected. So it should not hold the address of the previous node. So in the previous field, that is we have to assign the value null. So all these three cases we have to do it now. So first what we are doing, we are assigning the root value to temp variable. So here we are creating one temporary variable, and for that temporary variable we are assigning the root value. So my temp will be pointing to this first node. Next we have to move the root to the next node. So now the root should be pointing to this node. So how can we point to this node? What is the address of this node? 5048. What is 5048? 5048 is root to right. Root to right. So the root to right value we need to assign to root. Now we have to place the null value here. Understood? So we have to place the null value here so that this connection will get disconnected. So what is it? It is temp to right. So here temp to right, we have to place the null value so that this connection will get disconnected. So we are placing temp to right is equal to null. So automatically this connection we are going to lose. Now this connection also need to be null. So now we have to disconnect this link. So how to disconnect this link? It is nothing but it is, so now my root is pointing to this node. So root to left. So root to left value I need to place with a null. So my root to left value is null. So this connection is also lost. So now that this particular node is not having any connection with any of the nodes in the linked list. So we need to free this function because we are creating the nodes dynamically. We can reallocate that memory. So here in this case, what we need to do is we need to use the free function. So how to free this location? Because here the temp is pointing to this particular location. So we can free the location by using the temp. So here we write free of temp. So once when we write free of temp, this node will be free and we can use it for any other purpose. Now let us see how we can delete the node at the end. So here we will see how to delete the node at the end. Again we consider the double linked list with 4 nodes where the root is pointing to the first node. So the right link 30 should be null. So here since we are deleting the node at the end, now here the value should be the null value, and the tail need to be, because this node we are deleting, this will be our last node. So the tail should move to this location. Understood? So the tail should be the previous node. So here to do that, what I am doing is I am taking a temporary variable and I am assigning the tail value to temp. So now my temp will be pointing to 7056 because tail is equal to temp. So tail value is 7056. That value will be assigned to temp. Now what I am doing? I am shifting the tail value to this location. What is that? Tail is equal to tail to left. So this address is 9042. 9042 address is tail to left. So tail is equal to tail to left. So now my tail will be 9042. So tail will be shifting to this location. Now this value we have to fill with a null. This value we have to fill with null. And at the same time, we have to fill this value also with null. So let us first fill this value with null. So what is this? 7056. 7056 is 10. So here in the temp to left value, we have to place the null value so that we can remove this connection. So temp to left is equal to null. Now we are writing temp to left is equal to null. So this value became null. Now this also we have to disconnect this connection also. What is this? This is tail to right value. So we have to place the null value in the tail to right. So tail to right is equal to null. So this will become null. So this connection also we will lose. Understood? Now we have to free this particular node because it has no connection, so that we can reallocate this memory for other purpose. So how we write? We use by using the free function. So free of temp, because temp is pointing to 7056, free of temp. So this is the logic we use for deleting the node at the end. Now let us see the third case, that is how to delete a node at a specified location. Again, consider the same double linked list with 4 nodes like this, with the root pointing to the first node. So here first we have to read the specific location where we have to delete. So now if the specified location does not exist, then we have to display the message saying that it is an invalid location. So first we have to enter the location value. So if the location exists, say given the location 3, then what we have to do? If the location value what we are entering is 3, then we have to remove the third node. Okay, so to remove the third node, what we have to do is we have to take one temporary variable. One temporary variable. That temporary variable need to point to the root node initially. So my temp is pointing to the root node. Now we need to bring the control of this temp to this particular location. That is to the second location in this particular example. So how can we bring? We can either use the while loop or we can use the for loop. So here let us use the for loop. So for I is equal to 1, I less than location minus 1, I plus plus, I am assigning the temp to right value into temp. So here in this particular case, what is I value? I value is 1. 1 is less than location minus 1. That is 3 minus 1. So 1 less than 2, condition is true. So temp will become temp to right. Temp initially it is root. So 2046 to right value is 5048. So 5048 is stored here. Now my temp will be pointing to this node. Now I became I plus plus. I value 2. Previously it was 1. Now I plus plus 2. I less than location, 2 less than location. Location value is 3. 3 minus 1 is the 2. 2 less than 2, condition is false. So we will come out of the loop. By that time, the temp started pointing to the second node. Okay. Now what we have to do? We have to disconnect this particular node. And this node should be connected to this node. And this connection should be like this to this node. So here what we have to do? We have to make the connection like this. So this address 7056 value, we have to store it here. What is it? In the temp to right value, we have to store this 7056 address. So what is it? It is temp to right to right. 7056 value is temp to right to right. So that value we have to assign to temp to right. So when I say temp to right is equal to temp to right. So here temp to right is equal to temp to write. So this connection will be lost and this will be pointing to this location. Now after that, now I need to place the 5048 value here. So I have already placed the 50. How I have placed? That is nothing but see, you cannot write this tail 2 because maybe in this case this is the last node. But here how we are going to write is we are going to write temp to right to left is equal to temp value. So 5048 is the temp value. That is temp to right to left. In this particular place, what value I am placing? I am placing the temp value. Maybe in this, some of you may think the logic like this. In this case, it will be, you can say that tail to right, tail to left. This particular position is a tail to left. Tail to left is equal to temp. No, that logic is completely wrong. Because if we are having 10 nodes and if I am deleting the 5th node, then it will not be tail to left node we are placing the value. So the logic what we have to take here is a temp to right to left is equal to temp value. So now this connection got connected. Now we have to remove this connection and this connection. How to remove? No, there is no, because we lost the connection. This is connected to this and this is connected to this. For that, before writing these two statements, we have to declare one more variable, temporary variable p, such that p is equal to temp to right. So here temp is pointing to this node, then we have to assign a p variable such that p is equal to temp to right. Temp to right value is 9042. So 9042 value we have to do. Then we have to perform these two operations. Now I have to place the null value. So where I have to place the null value? I have to place the null value in the p2 left value as well as p2 right value. So here I write p2 left is equal to p2 right is equal to null. So both the values will get null. So we can remove these two particular connections. So these connections will be lost. Now what I have to do? I have to free this particular node. So can I free? Yes, because my P is pointing to 9042 address. Even if you are not going to do also, the program logic is correct. But if you free the memory, that memory can be used for the other purpose. So here the last statement what we write is free out. So this particular node will be free. So this is how we can delete the node from the specified location. That's all for now. Thank you. If you like this video, please subscribe to my channel and press the bell icon for the latest notifications. And don't forget to press the like. Thank you. Thank you.